Natalie, it looks like we're just past 1 o'clock. Shall we get started?
Yes, please do.
Okay, excellent. Well, hello, everyone. I am Jamie Paget from Rice University in Houston, Texas, and I am a co-PI on the DesignSafe cyber infrastructure, the NERI cyber infrastructure for our natural hazards engineering research community. Very pleased to introduce our speaker for today's webinar, Sabarithanam Kameshwar. But before I pass the ball to Kameshwar, I'd like to share with you a very brief introduction to DesignSafe. You'll be certainly able to find out more information about DesignSafe on our web portal today, including information on things like our training materials through the Learning Center. But I would, for those of you who may be first timers to DesignSafe, want to give a very brief overview of some of the vision and aims of the cyber infrastructure. The idea is that this cyber infrastructure is a part of our full research life cycle, meaning that we're not just looking at DesignSafe as a data repository or a place where we dump and share our data, but it's truly a dynamic and integral part of our research process. We tend to leverage cloud-based tools to support both analysis, visualization, and integration of various data types in support of that research life cycle. And DesignSafe is a part of the broader NERI network supported by the National Science Foundation. And one of the aims of that cyber infrastructure is to help to link and amplify some of the capabilities of the other NERI components. For example, some of the experimental facilities or the simulation center, and help to provide resources to our research community. The image here just gives you an idea of some of the different types of research that are enabled by DesignSafe. We have simulation-based research that is supported through the cyber infrastructure, and a lot of what Kameshwar will be talking to you about today is illustrating the support of that simulation-based research. Also, there's opportunity to leverage the CI to support experimental work or rapid and field reconnaissance work. And one of the kind of major hubs of the cyber infrastructure is this data depot through which we can store, share, and publish data sets emerging from these different types of research. Within the data depot, there's the opportunity to curate and publish those data sets, and I'll show you a little bit more about that in the coming slides. But also we have that opportunity for linking with some of those cloud-based tools to support discovery and analysis. For example, visualization and data processing that's integrated with that data stored in the data depot. In terms of transferring files and ingesting data into DesignSafe, certainly that data could be generated directly on DesignSafe in the case of some of the simulation-based work, but we often, of course, have the need to transfer files from other sources, whether it be some of that experimental data or reconnaissance data. And some of the various options are highlighted here, including the potential for interfacing with the data depot through Jupyter, the direct linkage with cloud service providers like Box, Dropbox, or Google Drive, particularly with some larger file upload and sharing, leveraging Globus, or options through the command line interface. And there is a data transfer guide that is provided on the DesignSafe portal that can help provide other examples and details on some of these file transfer and upload options. With respect to the philosophy of data curation on DesignSafe, the idea is to make this a very flexible and easy process without much constraint with respect to the data model or the curation process. So idea being that we can share and store and document that throughout the life of a project, as opposed to, say, waiting until the last hour and then publishing that data. It can be an ongoing process through the research timeline. I'll talk a little bit about some of the different data models that are already available, but the idea is to allow the researcher to have some of that flexibility and oversight on how they want to organize their data to share it, how they want to provide tagging with categories, for example, and allow that data to be discovered and understandable by outside users. Some of the various data models that are available through DesignSafe include an experimental data model, one for simulation-based research and for hybrid simulation. A field reconnaissance data model is being developed in collaboration with the NERI Rapid Facility, and a social science data model is being developed in collaboration with SCER. There is an other category as well that can be used if you don't feel that your data fits into one of these various categories, and there's also an opportunity to work directly with the team to help encourage and inspire other data models that can be useful to our research community. I think one great opportunity to take advantage of is the potential for virtual office hours with the data curator for DesignSafe, who is located at TAC, at the Texas Advanced Computing Center. Dr. Maria Esteva has office hours weekly. They are on Tuesdays and Thursdays at 1 p.m. Central, and the link for those Zoom meetings is provided on the slides here. You'll also find more information about that in our Learning Center. Just a quick preview of the data curation and publication pipeline. You can see examples here of the process of allowing for tree development by the users themselves in terms of assigning various structures and files to that structure for how you would share and organize your data, and then assigning those files to the various categories, for example, model, sensor, event, and so forth. And each of these individual tags is associated with some of those different types of data models, for example, the experimental data model. Once you've decided how you want to organize and share your data and assigned files to each of those categories, you go further through the publication pipeline and can see, for example, a preview of your data publication, and then ultimately may choose to publish your project. You do not have to publish all of the files that are within your project or that reside in your data depot. Only those that you select and tag as a part of your curated tree will be that's shared with your project. And of course, alongside that, you'll be providing other information on the project with respect to descriptions, potential funding information like award numbers, keywords, and so forth. One of the keys that you see on this slide is that once you hit that publication mark, then you receive a DOI for that project. And so that is a permanent DOI that's not just a URL, but that's a citable DOI associated with your project and its data. Certainly, we want to encourage not only that people are sharing and publishing their data, but that we make that transition to citing data sets themselves. So not just point to the fact that data was used from DesignSafe, but you can provide in your reference list the DOI for the cited data that will allow that link directly to your formally published data. And again, keep in mind that that data can reside in various forms, whether it be the processing scripts, the visualizations, or other forms of data that you may choose to publish and share. Also, this would provide an opportunity to now include, for example, on your CV, the link and the list of your curated data sets. In terms of how we actually would want to cite those, the DesignSafe Data Depot provides some guidance on the formal citation to the data sets that are published on DesignSafe. And here's just an example of the citation provided directly on the web portal, and then how that would appear, for example, in a publication. So certainly want to encourage our users and community to leverage that official citation format so that data sets, in addition to other papers and references, are included in our future publications. I now would like to pass the ball to Kameshwar, who will be giving us an overview today of an end-to-end workflow that's been leveraging the DesignSafe cyber infrastructure for fragility modeling of a portfolio of structures. Just a brief background on Kameshwar. He is an assistant professor at Louisiana State University. He received his PhD from Rice University and completed a postdoc appointment at Oregon State University. His expertise is in multi-hazard risk assessment and resilience quantification. And he'll be showing you an example of some of that type of work for a particular type of structure today using bridge portfolios within DesignSafe. So with that, I'll stop sharing my screen and pass the ball to Kameshwar.
Thank you, Jamie. Thank you for the introduction and the initial background on DesignSafe. That makes my job easier. So the objective of the presentation today is to highlight how we can use DesignSafe for simulation-based research. And I'll be taking an example of multi-thread bridge fragility modeling and show how we can model the bridge fragilities, and in general show how we can do simulation-based research from beginning to the end. So beginning meaning from conceptualization of the research and all the way to the end, where we have visualization of the data, and also we have data sharing and all of those things. So this work that I'm going to present today is a team effort. I have done this work with Navya Vishnu. She's a catastrophe modeler at AII, and also with Dr. Jamie Paget at Rice University. And a part of today's presentation is also to show the capabilities for collaborative research on DesignSafe, because when we did this research, we were all at different locations, and still we were able to work on it together wherever we were, because it allows that kind of collaboration. So in the outline today, I'll be mostly showing the research objective, the workflow, and then going through how we achieve our workflow on DesignSafe, and then moving down to visualization, how we see data, how we can present it to others, and finally discuss a little bit on how we can store data, because DesignSafe has primarily been used for storage. And I'll also talk about how we can store data for simulation-based data here. So the objective for us here was to develop parameterized fragility models for bridges so that we can apply them to the central and eastern United States as a whole, in a whole region. And we wanted to consider threats such as earthquakes, aging, and truckloads. And because we are trying to apply these models for the entire region, we want them to be parameterized, and we want these models for multiple bridge classes. So we have 7 bridge classes here. So MSC here means multi-span continuous bridges. So we have multi-span continuous bridges with concrete girder decks, concrete slab decks, and steel girder decks. And similarly, we have MSSS, which is the multi-span simply supported bridges. So we have different types of superstructure here. We have box girder bridges, concrete girder, slab, and steel girder bridges. And for these 7 different classes, we modeled the fragilities for earthquake and aging together, and then for and then for aging and truckloads together. So we have 2 sets of fragilities, and I'll be switching back a little bit back and forth between these 2 fragility models and show different steps in our workflow. So just before I dive into the whole workflow and talk about fragilities, I just want to give a brief background on what is a fragility and what are they used for. So a fragility is a conditional failure probability model, which says what is the probability that a demand is exceeding a given level of capacity. For given hazard intensity, which is IM, and X are structural properties. In our case, this is bridge properties. So this could be number of spans, length of spans, column diameters, column size, reinforcement, and all of those bridge parameters. So essentially, fragility is a conditional probability statement. For a given hazard, it tells us what is the probability of exceeding a certain capacity. And typically, we have seen that fragilities have been modeled using log normal distribution. So they have nice closed form solution, and therefore they have been used widely for probabilistic performance assessment, regional level risk and resilience assessment. And recently we have been moving towards parameterized fragility models, and that is what we will be seeing today. So as I said, we will be using parameterized fragility modeling. And for this, we use surrogate models. So the idea for surrogate models is that when computational simulations become really expensive, we want to substitute the simulations with using a simpler, easier model, which is a surrogate model in our case. And we use response surface-based models to parameterize the response of the bridges. And also we develop closed form log normal. So we also develop closed form logistic regression-based fragility expressions for the 7 bridge classes for the 2 different types of hazards that we are looking for. So the research workflow for this kind of research, which is, although I'm talking about bridges, but this is kind of similar for other research as well that includes hazard modeling. So even though we have bridges, it could be the same for buildings as well. And also there are specific methods that we use, but we can easily swap the methods because the general idea is pretty much the same. That is, first we have experimental design where we identify the primary hazards. So for example, in this case for us, we have earthquakes and aging and truckloads. We identify key parameters. So these could be hazard parameters, bridge parameters, and all other important parameters that we need to consider. And again, for bridges here, and then once we know what parameters we're looking for, we can look at what range of parameters we need to select. And then we can sample the parameters to do simulations because we're doing simulations-based research. So we need to generate combinations of all the parameters that we have and perform simulations. So this is the first step in the workflow, which is experimental design or setting up of the analysis. In the next step, we can do finite element modeling. In my case, this is done on OpenSeas here, but DesignSafe has a lot of other simulation tools which can be used, for example, OpenFOAM, AdCirc, different software that can be used for different types of simulations. Here, I'll be showing how we used OpenSeas for our simulations. And then the next step is fragility modeling, which involves post-processing of the results, modeling demand, capacity, and fragility. So this is in general a step which encompasses all post-processing, so which is data analysis and developing models. So again, I use MATLAB for this process, but it doesn't have to be MATLAB because DesignSafe also supports Jupyter notebooks, and we can also use other platforms if you would like to on DesignSafe. And finally, we can have visualization of the results. That is, we are now presenting the results. So this could be for our own purposes internally, for example, if you want to see how things look, or we can also publish or create interactive tools for where others can interact with our results. And I'll be showing a brief demonstration using Jupyter notebooks where we can create widgets where people can change parameters of the fragility and then see how the parameters of the bridges and see how fragility changes. And the final step in our workflow is data management. So to store, once we have done the research, analyze them, post-process them, have all the results that we need, how do we store them, and then what do we do with the data assets? So that is the final part of data management. I'll briefly be showing how we can do that on DesignSafe. So now I'll be moving on to the first step, which is the experimental design for the fragility modeling that I'm going to show. So in this case, we have bridges, and there are several bridge parameters that we consider as variables. So these include column height, so which is this column height, diameter of the column, which is, we are assuming I'm showing a circular column here, but across the 7 different bridge classes that we We do have different types of columns, so some of them are rectangular, some of them are square. So it doesn't have to be anything specific. We can pick and choose what we want to have. So in this particular case, we also have other parameters like span length, deck width, reinforcement ratios, rho L, rho T, material properties such as steel, yield strength, concrete strength. We also have geometric parameters other than the ones that we saw before. There is number of columns, number of spans, spacing between columns. And we also have aging effects. So those are essentially because of chloride induced corrosion. We assume that we assume some exposure conditions, and in time we find out how much deterioration can be expected. So that deterioration is modeled by reducing the reinforcement area and also by changing the stiffness of the bearing pads. And then besides these, we also have properties for the foundations, abutments, and the bearings that we have in our bridges. And in terms of loading, we have truckloads and earthquake ground motions. I'll come back to the details of truckloads and earthquake ground motions in a while. And to sample all of these parameters within a few combinations, I use Latin hypercube sampling here. So for each bridge class, we develop 1,044 samples, and each sample represents a bridge model. And for each of those 1,044 bridge models, we do finite element simulations on DesignSafe. And then we also have 108 test samples, which we'll be using for testing our surrogate models that we develop for our demand, capacity, and all of those kind of things. So here I'm just trying to show using a video how we can do all of this on DesignSafe. So this is, can you see the video moving?
No, it's not moving.
Huh,
Yeah.
okay, let's see. Okay, so let me try it this way. This might not be the best way, but. So I'm just trying to here show a video of how to start with all of this. So some of you might be familiar with this already, might have already worked on DesignSafe, but this video now we'll try to show how we can use DesignSafe for doing all of this research. So here I'm showing some of the key places, which is my projects and my data. So when we are doing collaborative research, we can use my projects. So for example, these two folders are the folders that we use for this research. And if we are starting a new project, we can add new project folders, and we can give any name, and we can also add new collaborators. For example, I'm just adding Navya here as an example. We can search people, whoever is signed up on DesignSafe, and we can add them to the project, and we can share files in this manner. In this case, I'm not going to add this folder to our case, but we can always do this. And the second option for data is my data. So this is the data that is personal, and only the individual person can use it. So here I'm showing the 4 folders that are related to the files that I'm going to show for the fragility models. But if you're starting a new project, we can also make new folders. And for example, in this case, I'm making a demonstration folder for MATLAB codes for the bridge post-processing. And once we have this, we can access all of these from many of the tools that we have on DesignSafe. For example, when we are doing this pre-processing step. So now we are looking at the pre-processing step where we can use MATLAB to generate our samples. So here we can just see all these different types of tools we have. We have simulation tools, we have different types of visualization tools, and we also have data processing tools. So my pre-processing happens in MATLAB. So I generate the Latin hypercube samples in MATLAB. So I'll be launching a MATLAB job here. So we have different versions of MATLAB, which is 2017, 2019, and all the way in different batch mode and also interactive mode. The one that I'm launching here is in interactive mode. So there are several options that we can choose. For example, we can select the desktop resolution. So I pick a resolution that fits my monitor. We can say how much time we need to use the MATLAB on DesignSafe. For example, I'm saying I need to use it for 2 hours. Right now, we can give a name to our job, but in this case, I just leave it as whatever we have default. And also we can give a location where it will archive any outputs from this simulation or from this job. But in this case, I just leave it as default. So when we hit run, it just submits the job. It sometimes takes a while. I mean, it doesn't take long, but a few seconds. And we can also check the status of the job up here on the job status bar. And right now it is telling us that it is staging the job. It means it is copying all the files that it needs to run the job or execute the job. And on the bottom side, you can see the pop-up coming up, which shows that what's the status of the job, and it keeps on updating the status. Once the job is ready, in at least in MATLAB, you'll see a screen pop up like this, and we can just simply connect, and we have a MATLAB session which is running right now. And so this is just MATLAB, and we can start working on it as if we were working on our own computers and start typing and creating new files. So again here, so I'm just creating a new file. And the key thing here to note is we can access all of our My Data and the My Projects folder. So if we have a shared project folder that we are working with someone, we can just work on files and share them together at the same time. So I'm just starting to work on a file here, which is for the pre-processing and which does Latin hypercube sampling, which for us in the research workflow is the step 1, which is experimental design. So this is just creating a file for Latin hypercube sampling. The next slide I'll cut to the next demo, which just like shows what's the next step. So for example, if here, so once we have the file which is ready, so in this case I just have this one, and we can save it wherever we like. We can save it to My Data, and I'm going to save it to the MATLAB codes folder that I just created before. And we can continue working on it and save changes as we would do normally on our own personal computers, but we can do all the same things on DesignSafe. So we can continue working, and now I'm just skipping to the part where I have finished coding the Latin hypercube sampling code. So we have about 40 something parameters that includes geometry, the material properties, hazard properties, and all of those. So this is just initially defining the bounds of those. And as I mentioned before, we have 1,044 samples for training. And for these 1,000 samples, I'm just generating the parameter combinations. And we have some other post-processing. And finally, like we would do on our regular MATLAB codes, we can also save the data on My Data or in My Projects folder, wherever we want to save it. So I run the script for experimental design. And once we run it, we can see on the command window that we have saved. So this is the saved file, which has all of these parameters, for example, for area of deck, deck width, number of columns, and all of those kind of things. And we can use it later on if we want to use it for finite element simulations. And we will come back to this on how to use it for finite element simulations. So the next step in our workflow is so if we go back to the workflow, the next step is experimental. So we have finite element modeling. So we have finite element modeling happening here. So for finite element models, we have different components in the bridge. So we have bearings, which is a combination of steel dowels and elastomeric bearing pads, which I'm showing here as a schematic diagram. So this is just a specific case for concrete girders. So we have the girder, this is the bridge bend. In between, we have the bearing assembly here. So these are the elastomeric bearing pads. And this is for the fixed bearing, and this is for the expansion bearing. And we can see how they are modeled. So we can see they are modeled using a parallel combination of the dowel and the bearing pad, which is similar to the case that we have for abutments, where we have active and passive soil resistance. So we have combinations of springs that we use to model these abutment springs. Similarly, for foundation, we have springs, but we restrict the degrees of freedom in the vertical direction and in the torsional degree for this foundation springs. And when it comes to the bridge deck, we also have a much more complicated model here, where we model the bridge deck using a grillage. So idea behind using a grillage here is that we are also looking at the service load reliability of the bridge, where we have trucks passing on the bridge, or in this case, we just keep the truck static and find out what is the moments and the shear demands on the girders and how they change with time as their capacity reduces due to deterioration. And finally, this is a schematic diagram of the entire bridge, so which shows the columns, the foundation springs, the abutment springs, and the deck grillage as a whole. So finally, when we come to the finite element modeling, the next step is modeling loads. In this case, for earthquakes, we have ground motions. So we have ground motion suites from Rix and Fernandez and Wen and Wu. In total, we have 348 ground motions, and we have 1,044 bridges. So we just randomly assign different bridges to different ground motions. And for truckloads, we consider an HS20 truck, and we assume that it's a static point load as far as modeling is concerned. So we just put these point loads on the deck grillage anywhere in the grillage here, and determine what is going to be the performance of the deck and the bridge as a whole, including columns and bearings and all other components. So once we have all of this, we can see how we can use DesignSafe for performing finite element simulations on DesignSafe itself. In this case, we have 1,044 bridges for earthquakes. Each bridge, because we have a grillage here, it takes about 6 to 7 hours. And if we have finite element models already, we can see that we can download them from Box, Dropbox, Google Drive, or we can also bring them in from different from Globus as well, if you would like to do that. Or there's another straightforward way, is that we can just simply add files or download or upload files here. So for example, I'm just showing an example here how we can simply upload files. So I'm just creating a new folder where we will have OpenSeas codes for bridges. So once I create the folder, I can go inside the folder and I can upload more and more data. So I'm going to add a file. So what I have found typically is that adding files in a zip file is the best way. When you have multiple small files, for example, I have here MATLAB, I have OpenSea scripts, plus I have the ground motion scripts for the 348 ground motions that I have. So I have the acceleration files for the ground motions in 2 directions, X and Y. So that's a lot of small files. And when we have to upload those, the easiest way is to just upload a zip file. And we have tools on the workspace here that can be used to unzip and zip data. So for example, I'm just showing here how to unzip the zip file that we just uploaded. So we can select. So on the left, we are selecting where our zip file is. So this is where the zip file is. We can select one. So we select this zip file, and next we can tell where do we want the unzipped files to go. So this is what the output directory is. And I select the OpenSeas codes folder, and then we can just tell how much time do we think. It doesn't have very many files, so I know that it's going to finish within a couple of minutes. We can give a meaningful name to the job, but for these jobs, it's not really necessary. And it's similar to what we had seen in the case for MATLAB jobs. It will come up here, the job status will come up here, and we can see the pop-ups coming here, which is going to update the status of the jobs, saying, okay, what's happening. Right now it's saying that the unzipping is going on, and we'll soon see that it will finish. And this is all happening in real time, in the sense that I'm not speeding up the video or anything. This is how fast it is. So once we have the unzipping finished, we can go back to our data depot and look at the unzipped files. So this is the unzip folder. And here, if you look at it, we have different files here. So these are all the different components of the bridge, columns, bearings. And one of the things that we have is parameter value.ab. So these are the parameter values that we are going to give as inputs to our OpenSeas code. So here, each parameter combination is a bridge. So the ones that we just generated in the first step, which was the experimental design, we will be copy pasting those values from MATLAB into this file, which is what gives the inputs to our OpenSeas simulation. So I'm just going back to the MATLAB job that was running before. And if you just close the window for MATLAB, it doesn't stop the job. It just, it's always going on. So this is picking up from where we had left before. So we can open up this training data, which is the Latin hypercube samples that we had. And we can open up, and so here I'm loading it. And I will open the training data, which is in this variable xtrain, and we can copy all of this information. So for example, here we can see 1044 parameter combinations and for 43 parameters. So this means 1044 bridges and 43 parameter combinations. I copy all of this. And the good thing about the interactive session in MATLAB is you can access all of your My Data and My Projects folders as if they were on your computer here. So we can see that I can go to My Data, and I can go to the OpenSeas codes folder here and edit the parameter.value.ab.file. And not only this, we can also edit our OpenSeas files here. So any tickle codes that we have, we can also edit them right here, and we don't have to worry about uploading them again or having forgotten that we have to change something. So here I have an empty parameter.value file, and I'll just simply paste all the Latin hypercube samples here so that OpenSeas can directly use it in the simulations. So this goes all the way up, and we can see that we have all the parameters in our, so all of these parameters are here in our parameter.ab.file. So we can save this, and it'll just as if we are saving it on a computer, and then we can also go and change our tickle files that we need to change for running the OpenSeas code. So for example, here, my main tickle file that has to be run is called a2.tickle. And so this is a tickle. So for example, now I want to change this, because earlier I had set up the code for 697 bridges, but now I have 1044. So I can change this to 1044. Similarly, the code here can be changed. So I was just testing one case, bridge number 6, but we can just change all of those. And one of the key things here that I want to point out right now, which I'm highlighting here, is the set of lines that we need to put in for parallelization. One of the key advantages of DesignSafe is the sheer volume of computational power that we get. And we can use the parallelization capacity for OpenSeas as well. And here we just add these 6 lines, and it just runs OpenSeas MP in parallel. Although my approach here is using a cloud-based approach for fragility modeling, but we can still make our tickle files such that they can also work for other types, for example, IDA or incremental dynamic analysis. So in the next one, so this is the next step in our analysis. We go back and run our simulations. So now I'm creating a new folder for the output of my simulations. So whatever simulations we will be doing, we will have outputs from that, and I'll be just storing them in a folder here. So I'll skip a little bit ahead. So now we can go to OpenSeas and submit a OpenSeas job to run the files that we had just changed. So we have different versions right now. OpenSeas Express, this is a serial version, just one OpenSeas MP is for the massively parallel, and OpenSeas SP is for cases that where we have a really huge problem. For us here, bridges are not that it's a matter that it's a time series analysis, so it takes a long time, but it doesn't require huge memory or anything. So if we required huge memory, we would have to use OpenSeas SP. So again, like before, I'm specifying where my input files are, specifying which file to run, how much time. So in this case, I'm setting it for 48 hours because that is how much time it needs. And I'm just giving it a name so that I remember which bridge class I did. So I'm just showing one example here, but I had done multiple bridge classes. So therefore I give a different name here so that I can keep track. And we are selecting the simulation output file locations. And finally here, this is one of the key things is the number of nodes. So each node is like a computer and each node has 64 processors. So that means I'm going to run 768 OpenSea simulations at the same time parallelly. So this is the main advantage of using DesignSafe, that we get massive computational power. So again, like before, we can see the status of the job will change here. After 48 hours, I would get all the simulation results for this one. So I think, yeah. So once we have the simulations done, the next step for us here is post-processing of the data. So this is step number 3 in the workflow, which is post-processing, and that also includes fragility modeling. So in our case, we have demand models. We use response surfaces or polynomial response surfaces to be more specific to model the demand. And we do try different types of surrogate models, for example, response surfaces, support vector machines, regression trees, but we finally stick to polynomial response surfaces because they perform really well for us. And in this research, the capacity models that I have used are log normal capacity models. For example, here I'm showing the capacity models for columns in terms of their drift ratios. And here we have different capacity models for abutments and bearings and different other components. And for fragility modeling, I use stepwise logistic regression. I use stepwise because that doesn't entail any parameter selection from our side. It automatically selects the key parameters that are going to give the best fragility model. And then once we have, so this, for example, shows the failure and the safe samples. The logistic regression model is supposed to separate the failure and the safe samples in this form. And finally, if we have a parameterized fragility function, which is this logistic regression, we can change our parameters or intensity measures and see how the fragility looks like. So for example, here I have a fragility for a bridge column with intensity measured as spectral acceleration at 0.5 seconds and how it changes with age of the column. So now I'm just going to show again the same post-processing steps on how we can do it on DesignSafe. So like before, I have a code here which reads the results of the earthquake simulations. I can hit run, and we can see that I have 1,044 bridges, so it keeps on going. So I'll skip to finally when we have done all of those simulations, and we can see all the results that we have here. We can save them as we would do normally on any computer. We can just simply save them. I just call them results.mat. We can save them here, and then we can use these for post-processing and developing fragility models. So this one here shows how we do the stepwise logistic regression on DesignSafe itself. So I have so this is the code that we have for demand modeling using response surface models, and then finally for fragility modeling using stepwise logistic regression. So all of the codes, so all the data from this study has already been published, which I'll be showing you right now in a few minutes. But all these codes will also be published eventually. So within a few months, we are planning to publish all of this data, these codes as well. So if anyone is interested in using this data or our OpenSea codes or our MATLAB codes, they will all be available. OpenSea codes are actually available on DesignSafe right now. So once I run, again, I'm doing stepwise response surface modeling. So because it's a stepwise model, it's adding one parameter at a time, and it will keep going like this. So we will have a response surface model. So this is the response surface model, and it is showing the prediction capabilities, for example, R-square values, mean average percentage errors, and all others. And the code next goes on to do stepwise logistic regression. So again, being stepwise, it adds one parameter at a time, and it keeps going, and finally it finishes, and then I print out the confusion matrix here, which shows the cases which it predicted very well and where it had errors. So in this case, we have a really good logistic regression model. So with this logistic regression model, we can do data visualization and also visualize the results. For example, typically what we would do is make figures and see how it looks like. So for example, in this case, I'm showing the effect of different parameters on the girder deflections. So we have span length, number of girders, girder spacing, and again, all the way up to truckloads. And we can see how any change in any of these is affecting our deflection of the girders. And similarly, now I'm showing the fragilities for the bridge with truckloads and aging. So we can see as the truckload increases, the fragility is increasing, and so does the fragility increase with age as well. And this is in terms of exceeding a deflection limit, and this is for exceeding a moment limit state. And this is an example for the columns fragility for slight damage state. So in this case, typically this is what we would do is we would have some intensity measure, but in this case, we also have aging. So we also have aging parameters here. But another thing that is useful in DesignSafe is that we can use a lot of visualization tools. So all of the stuff that I have shown so far is using MATLAB for post-processing and visualization, but we can also use Python using Jupyter Notebooks. I just want to show an example of that and also show how we can use Jupyter Notebooks for visualization of our results. So I just created a widget. So this is the widget in, I think this example is already available publicly. So this widget creates an interactive means to show how the effects of different parameters can be studied. So for example, this is showing the fragility curve, the typical fragility curve where we have intensity measure and the column fragility. We can change, for example, the decrease in the rebar and see the fragility increased. We can increase the column diameter and see immediately how the fragility curve changes. And we can do these for all of the parameters that we have. Span length increases. We can see the fragility shifts left, meaning the fragility increases. And we can play with the same, all the parameters that we have here and see immediately how the fragility curve shifts. And I think this is very useful to present on a website. And because this is Jupyter Notebooks, it can also be embedded on websites and helps to see the data a little bit better and gives an interactive means to present the data. So finally, the last thing in our workflow is data management. In this case, we can use DesignSafe for data curation, which has been one of the main uses for DesignSafe so far. So many of you might have already published. So these are the 4 folders that we have already published, which include the OpenSeas codes and the simulation results. And so I'm going and showing here where we have this simulation data published. As far as data curation goes, there is several different ways in which we can arrange our data. So for example, the way we have arranged is so this is the DOI for the data that we have already published. And if we go down here, we can see the way we have arranged the bridges. So we have different types of bridges. So multi-span concrete girder bridges, the input files for those, the output files for those. We can also have read reports, which are descriptions or README files. And I think in this particular case, for data curation, Dr. Maria Esteva, she holds office hours, online office hours, and those are very useful because she helped us really on how we can organize and categorize our data so that it is easiest for people to come and use our data. And this is the DOI where we have published all of the data for the results that I showed you. So we have OpenSeas codes for 7 bridge classes and simulation results for earthquakes and for truckloads for all of the 7 bridge classes. And each bridge class has 1,100 something simulations. So it's a huge data set that anyone can use and work off of that. So finally, the take-home message here is that we can use DesignSafe for end-to-end simulation-based research, in the sense that we can start from the very beginning where we are conceptualizing our analysis. So we can set up our experiment, the computational experiment. We can change or create our finite element codes. In this case, I have used OpenSeas, but DesignSafe has other finite element softwares like LS-DYNA as well, or other simulation software, for example, OpenFOAM. So we can create our input files for these finite element softwares here alone, and then we can run them. We can post-process them, and we can also visualize and share and store data. And specifically for the fragility modeling, we see in the sense that for fragility modeling, key parameters that affect the seismic fragility that we found out from this is aging, bearing properties, and geometry. Whereas for truckloads, mainly it was span length and the girder properties. With this, I'll stop my presentation, and if you have any questions, I can briefly answer a few questions, I think, if we have time.
Thank you, Kameshwar. Yes, I suggest that if anyone has questions, you can type them into the group chat if you would like. I haven't seen any up there yet. Or you can potentially unmute yourself. Or Natalie, do you have everyone muted?
Everyone is muted, but they can unmute themselves if they'd like. But typing the question is actually best.
Great. So if we'll wait a few moments to see if anyone has any questions. I'd like to type into the group chat for Kameshwar. So perhaps while we are waiting to see if there are any more from the audience, like Kameshwar, I have one question for you, just for kind of broader consideration about using this platform for this type of work. So I envision that your workflow is very similar to others who are looking at fragility of especially portfolios of structures under different hazards, whether it be wind-induced loading or earthquake ground motions. Relative to, say, potentially using your own kind of on-campus HPC resources, what for you would be the motivation or the potential advantages of doing this on DesignSafe?
I think one of the key benefits of doing it on DesignSafe is collaboration, because we might have people from other places, other universities who may not have access to the on-campus computational facilities, and not all universities have on-campus computational facilities. So one, having this much computational power is useful, and the second thing is collaboration. So if there is a team of people working on a project, they can all work on the same things at the same time, and that's really one of the key aspects. And also another thing is data storage. Local computation clusters on universities typically remove data, and it is on us to store data wherever we keep it. But on DesignSafe, the data is safe forever. I mean, almost forever. So in this sense, DesignSafe has some benefits over local clusters in universities.
Okay, thank you. So I did see a couple of questions come in from the crowd. The first one I think is directed towards you, Kameshwar, which is from Jay Puckett, asking if the results you showed, if the bridge data that you showed is just to demonstrate the DesignSafe capabilities, or is this your real research product? Are the results demonstrated valid?
So this is real research. This is not just for show. This is actual research data that we have, and the results that I showed you are also valid. So and we are actually in the process of writing a paper right now based on these results, and yes, so all of these results are valid, and this is true research.
And then there was an additional question that perhaps may be more appropriate for the DesignSafe team. And I can't recall our data storage policy. Charlie and the audience may recall. How much data can we store on the data depot? Finite element simulation results like the ones Kameshwar showed could take a lot of storage space.
At this point in time, I don't think we are limiting people to the amount of data they can hold on DesignSafe, but that may change as more and more people start loading their data here. But
Right.
Right now, we have plenty of data storage available.
So for 8062, I think that's Aldu, there are different types of allocations. I think every DesignSafe member, when you sign up for an account, you get an initial allocation, more or less, to test the system. But then you can request additional storage capacity based on your research needs. And I have yet to hear of a research user requesting anything that exceeded the capacity of the tax system. So I think our wish would be that indeed we do have high demand for storage of usable research data. So we'd love to test the system and try to even find those limits from more of a research perspective. I think there was another question that came in.
That's from Merle.
From Merle, thank you. How busy does the DesignSafe computational resources get? So this is probably more of a TAC question than a Kameshwar question.
So just to answer you quickly, our resources are highly utilized, but we do have a reservation in place for DesignSafe users to be able to run their jobs through DesignSafe on our systems. If, however, you do run a job on your own outside of the DesignSafe environment, then you use the regular queue that all of our other users do as well.
Thank you, Charlie. I see one that's for Kameshwar about the joint seismic and aging fragility models. How did you get that combined earthquake and aging fragility curve, and did you apply something like total probability theorem?
Yeah, so for the bridge fragility, which combines aging and earthquakes, so what we do is we keep the aging related parameters, for example, decrease in the rebar diameters, as a parameter in our experimental design. So one of the parameters for our bridge fragility modeling is the rebar area. So we reduce the rebar area and we relate that to exposure conditions. So for example, if we have exposure conditions due to coastal conditions, then we know how much chloride ingress happens in a particular amount of time and how much corrosion we can expect. So accordingly, we can reduce the diameter of the rebars in the columns and all of the bridge components, and we can estimate what is the failure probability. So it is like having multiple intensity measures, but instead we have two different kind of hazards, and we have aging as a threat, which is a kind of in age, for example, of a bridge it's not really an intensity measure, but we treat it like an intensity measure.
And then perhaps, I'm not sure if you've come across this in your own work, Kameshwar, about monitoring memory usage. If you used OpenSea's MP at all in your simulations and tried to monitor the memory usage on each node?
I have never tried to monitor memory usage because the simulations that we run, or I have shown today here, are not memory intensive. But I think there should be enough memory. I think there is on DesignSafe page, there is the amount of memory that is allowed, like the maximum memory on this system on each node. But there might be an OpenSea's trick to do that, but I'm not aware of that right now.
Yep. Yeah, I am not either, but that may be something that we pose more broadly to the OpenSea's user community, including that on DesignSafe. So I think we should flag that one for potential follow-up. Any last questions from the audience? Okay, I may take the ball back from you, Kameshwar, and
there's one more question.
Oh yeah, thank you, Charlie. Will you monitor field that?
Yep. So the question was for MATLAB, is the DesignSafe team considering introducing multiple nodes as well? Yeah, that is something that is in works right now. We're still testing it to see how feasible and how well it works, but we haven't opened that up yet. Hopefully that'll go into production soon.
Okay. Any last comments from the audience? All right, can you see my screen again? I think it's not presenter view, but maybe you can see my slides.
Yeah, we can see them.
Okay, just before we wrap today, I just want to thank Kameshwar very much for his time and sharing his experience with using DesignSafe for the collaborative research project. And I certainly enjoyed the opportunity to collaborate with him on that as well. This, along with all of our other webinars, will be archived, and you can access those through the DesignSafe portal. The slide here is just showing you a reminder to go to the Learning Center, to the education and training links, where you'll see not only our upcoming training calendar, but also the archive of the recent DesignSafe tutorials in terms of those webinars. And we do have a specific DesignSafe YouTube channel where you can go and see all of the former archived videos. So we'll have that posted to share with you from today's video. Want to acknowledge, in addition to Kameshwar, some of our other team members on DesignSafe, including the various co-PIs and some of the staff and team at TAC who are working on the project, including Charlie Day, who's our training lead, who you've also heard on the call today. There are various ways to find out more and to get help on DesignSafe. Within the help menu, you'll see some resources with respect to training guides. We also have a Slack channel, and I encourage you to join the DesignSafe Slack channel if you're not on there. There are various different links, including just that general questions, as well as some special topics that may be of interest to you. Our email is listed, and we have a ticket system as well for various questions. So with that, I think we'll wrap for the day today, and hope to see you on some future webinars and to contribute to improving DesignSafe for our research community by providing some feedback to our team as well. So thank you very much, everyone, and I will sign off from this end.